everyone, I'm Hamid from DTU Smart Thermal Energy Systems Group, and in this video I want to introduce Aspen Exchanger Design and Rating software. This software is developed by Aspen Tech company to design different type of heat exchanger. In this video we are focusing on designing plate heat exchanger. For this purpose, I have prepared two examples. Example one is a condenser and example two is one evaporator. Okay, let's start. Here in the main page of the software, you can see different type of heat exchanger and select desired heat exchanger. For our example, we select plate exchanger and click on create button. This is the main page for the plate heat exchanger. Before we start the information of the hot stream and cold stream, we should set units. Because our units are SI, we select SI. In this window or in this tab, we should input the information for hot stream and cold stream. And we know about the information of the hot stream and cold stream. Okay, the name of hot stream is water and the name of cold stream is coolant. The mass flow rate of the hot stream is 0.55. The input temperature is 50 degree and also the output temperature is 50 degree. But the amount of mass flow rate at input is 1 and amount of vapor mass fraction in output is 0. The pressure is about 0.123 and the amount of heat transfer between two streams we should input from our example into the software. It's about this value. Okay, for the hot stream or coolant, we don't have any information for mass flow rate, but we know information for input temperature and also output temperature. The input temperature is 25 and the output temperature is 40, and the amount of vapor mass fraction for both in input and output is 0, and the pressure, the amount of the pressure is 1 bar for cold stream. Okay, this tab is completed, and one point is that for the pressure drop, the software is estimated 10% pressure drop for each stream. The next step is to select the type and properties of the fluid for hot stream and cold stream. Okay, let's go to the hot stream. We should go and select one library. I think the better library for this heat exchanger is BJack, and from this we should select our fluid. The fluid is water. We search the fluid and add to the system. Okay, and in hot stream properties we should check the amount of the pressure. This pressure is exact equal to pressure we have input in this section. Okay, for the cold stream also we select the library BJack and our fluid is water. We search water and add water to the system. The amount of the pressure for cold stream is exact equal to pressure we input for the cold stream. Okay, I think everything is okay. We go to the next to check input information. Everything is okay, and we select yes to run the software. Everything is okay. There is no error and warning for the system. We should go to the thermal hydraulic summary of the system. We have different tabs. Two important tab is overall performance and resistant distribution. Overall performance, you should see the different uh, properties for the hot stream and cold stream, amount of mass flow rate, input temperature, outlet temperature, and other things, and also the amount of total heat exchange between two streams. Also from the resistance distribution, the amount of required area for the heat exchanger and also overall coefficient for the two part of the heat exchanger is calculated. Also, another information or result is mechanical summary for our software, geometry of the basic geometry for plate heat exchanger. Also, we can see exchanger diagram for the plate heat exchanger and amount of cost and weight for this software. Okay, let's go to select another example. The another example is evaporator, and we should select plate exchanger for this purpose and select the unit and set the unit to SI. Here, the name of hot stream is oil and cold stream is water. For water, we have the information like here for the water, the amount of the mass flow rate, the temperature is in input temperature and output temperature. The input temperature, the situation is liquid, and output temperature, the situation is vapor. The amount of the pressure is about 1.757. Okay, for the hot stream, we don't have information about the mass flow rate, but we know the temperature for inlet and outlet. For the inlet, we should input this information for the temperature of input, and for output or outlet, the temperature is about both input and output are liquid, and we should uh, 0 for vapor mass fraction. The amount of heat transfer exchange between two streams is about this value. Also, the operation pressure for the hot stream is about 1.5. Okay, everything seems okay. Go to select the properties and type of fluid information. For the hot stream, we should select the BJAC library, search the data blank, and for the oil, we should select different type of terminal oil. We should select terminal oil 66 for this hot stream. And the amount of the pressure is exact equal to pressure we input in this tab. Also, for the cold stream, first we should select the library BJAC and search in the database or fluid is a water. We should water and add water to the system. And the amount of the pressure is exact equal to pressure we input in process data. Everything is okay. select to the next, and the program is run. We received two different warning, but this is only warning. We can don't care about this warning and go to the thermal hydraulic result for this evaporator, overall performance of the system, the amount of the mass flow rate and different information, and also resistance distribution, required area, and overall coefficient for this purpose. Also, for this evaporator, we should see the result of the exchanger geometry, basic geometry, exchanger diagram, and also cost and weight for this system. Thank you so much for your attention. If you want to select this video, please go to our YouTube channel to this address. Thank you so much.